Hi everyone, my name is Oliver. This is about, it contains the evil word JavaScript. Who likes JavaScript in this audience? Seriously, I'm surprised. That's great. I mean, perfect. So I tweeted the slides. The slides are also up here. This is my Twitter handle, DJ Korthose. It's funny in German, so I'm German. But, or embarrassing in German, but in Swedish, obviously not. I have two disclaimers. The first one, I thought the previous presentation was great, and I learned a lot, but I'm not very good at theoretical things. I'm a practitioner, so I use TypeScript and Flow, two of the type systems I will show today, in real projects. And Elm, the third type system, I've played around and people explain things to me. But I've never used it in something real, it's just toy projects. Second one, I don't have a single cat image. Not a single one. And even worse, I don't have any images. I just found out, I just have code. But to compensate for that and make it a valid presentation, this is my cat. This is. Did you know that cat looks like this? When you make a photograph from underneath? I have no idea how they did it. Probably it stands on a glass table or something. But didn't you know it? It's nice. The paws, look at it. Okay. No more cat pictures from now on, unfortunately. So, we're at a Java conference, so probably you like type systems, but still, why would you use one? From my experience, type systems make maintenance of code much easier. And in more detail, it makes code more readable, like the real annotation. It makes code easier to analyze for your IDE. That also counts for the inferred types. So even if you don't put the type there, the IDE can still know, oh, this is of this type. And this is like a prerequisite for refactoring. If you don't have reliable analytics for your code, the IDE is not good at refactoring. Who has ever tried to refactor JavaScript? Who likes it? Did it work? For whom did it work? Reliably, I mean. No hands for the camera, not a single one. My hand has to go down as well. That's a bad thing. If your project grows, if it lives for long and you can't refactor, that's a bad thing. And even if you click on show references, it doesn't work reliably for JavaScript, and it cannot because it misses the type information. It also can catch some errors, not all errors, of course. I mean, logic errors, if you just program nonsense, it doesn't catch it. And Anders Herzberg, the creator of Turbo Pascal, and then, who knows Turbo Pascal? Turbo Pascal, anyone? Yes, good. I'm not the only one who got educated in the 80s. So he said, big JavaScript code bases tend to become read-only. And I agree, at least from my experience. So we have three type systems. The first one, TypeScript. And its mantra is ease of use and tool support over soundness. It changed over time. So it does much better on soundness now, but it started like this. Second one, so TypeScript is from Microsoft. Second one, Flow. This one is from Facebook. And its mantra is soundness. It tries to be as sound as possible. And it tries to have zero runtime exceptions. It tries to, so no null pointer exceptions, no undefined is not a function exceptions. And then finally, Elm, it is about simplicity, which is, let's see. It's also about soundness. It's also about no runtime exceptions, but it's not object-oriented like JavaScript or Java. Well, JavaScript, it's debatable, but it's functional. You understand that. I will show loads of code. So, to get started, because I will show a lot of code, first I will show you some TypeScript in Visual Studio Code. And the fun thing is that, give me a second here. The fun thing is that this thing here, this is Visual Studio Code, it's implemented in TypeScript. Well, I'm using something implemented in TypeScript to write TypeScript, like IntelliJ IDEA, which is also used in Java. Written in Java. Okay, what can you do? So let's start something. This is valid in JavaScript. You see the compiler running, not a problem. This is a TypeScript file now, and it doesn't contain type annotations. But I can put something there, so like number. Same program does the same thing, but now it's clear A has to be a number. And obviously, if I do something like, I don't know, try to assign true to it, the IDE tells me, not possible, it's not a number, no coercion here. Typically, JavaScript would try to convert that, and it would, I think, turn it into 1, surprisingly. And also the compiler tells me, not possible. Good thing. Then there's functions. I don't know, do something. And I can pass in something as a parameter, param. I can also give it a type, let's see, string. No, let's say number again. And I can return something else. No, let's do a string here. You see the type annotation is behind the variable or the parameter, separated by the colon. That's different from Java, but other than that, it's just like Java in that sense. So I remove this because it's not valid. And now what I can do is I return something, I don't know, prefix plus that parameter. And I call it, do something. You see the code completion, which is possible and also knows it's a string. But look at this. Look at the signature of that function. It knows that it returns a string, right? You see it here. But I haven't typed it. This is because TypeScript can do type inference. That means it knows, okay, you pass in a string. I know for sure. You concatenate a string to a string, that for sure returns a string. So it knows the signature of this function obviously is string, so you don't have to type it. You can, but you're not forced to. In this case, I would do it because it helps documentation. I mean, you just look at the method or function signature. In that case, I would do it like this, but you're not forced to. You're not even forced to actually put this thing here. Let's see. Now, it still says you can pass in whatever you want, any is whatever you want, but it still knows that it returns a string, because if you concatenate something to the string, if you prefix it with a string, it will be string. Okay, I'll add the string again, because this is my preferred solution. It now tells me, okay, you're missing the parameter. Punch it in, it works. JavaScript has classes. Who knew that? Classes in JavaScript. Most people. But what it did not have, and it may get it soon, is fields or properties like in Java. Let's say the person that has a name. This is not possible in Java. In JavaScript, I'm sorry. And constructor, this again is normal JavaScript, and then this should look familiar to you. It's like a constructor in Java, just a little bit different syntax, and you also have to write the same stuff here. That works. You see the IDE also notice, or can tell you with using code lenses, that you have 0 references to that person because no one uses it. This is possible because of the type stuff. And you have 1 reference here, and if you're not quite sure where that reference is, you can click on it, and you see it right there in the constructor, okay. Which is a nice thing, provided by Visual Studio Code. Okay, then I can create a person, pass in the name, Oma, which means granny in German. And now, all of a sudden, you have 1 references, and you could also find references now, pretty much like in Java. Okay, this is the basic stuff. There's also methods, of course. What can you do on a person? Call it? No, I don't know. Say hi. So that the person say hi, and then, I don't know what you would do. You get the same things here as in normal functions, so you can have parameters or not, and you can also pass something back. So same thing. You can also have static fields, can also have static functions. Pretty much like in Java. It's of course inspired by Java and then also C#. Okay, this is more or less the basic stuff in TypeScript. So we can skip that. Flow is the next thing, but we can also skip flow because the basic stuff in flow looks exactly the same, exactly. Sometimes it has tiny difference in semantics, but we will come to that. So the basic flow example looks exactly the same. And even if you just use what I just showed you, just this stuff, there's much more, of course, because we still have 40 minutes. There's much more. You still get all the the good things of type systems. Like you get support, you get refactoring, you get IDE support, like reliable IDE support. Even with those features I just showed you, using just them. Then there's Elm, and Elm is totally different. And it might get a little bit more tricky here, but it's not, most of that is syntax for now. So in line 2, you see that I also declare that foo, which is a variable, is of type string, and in line 4, I assign yo to it, and that works. Now, in line 6, I try to assign something else, but that doesn't work, because everything in Elm is const. You just can't do it like final in Java. It's not possible to reassign. You can't. Also, same thing, line 8, I say foo2 is of type string, and then if I try to assign an int to it, it doesn't work, because types do not match. And this is also at compile time. So Elm compiler tells you before executing, not possible. Then in the second block, line 3 is actually a function signature. So the function is called sayIt, and it takes a string and it returns a string. And in line 4, you get the method body. It's just syntactically strange. It's very simple. So sayIt is the name of the function. What is the name of the parameter? And it returns a new string, and instead of just 1 plus, you use 2. This is just the way you do it here. And then in line 7, you declare another variable, set, it's of type string, then you call that function, pass in this object up, where is it? We don't have it. Let's say it's whatever. Let's say it's foo. Then you pass in the foo into this thing, and you get a new string. It looks very different, but for this basic stuff, it does the same thing. By the way, if there are questions, anytime, please. Questions so far? Okay, good. There are no classes, and thus no methods in Elm. So it's not object-oriented, which is strange because it compiles JavaScript, it lives in the JavaScript ecosystem, and people actually use it for real applications. It's not like, I don't know, other more academic languages. Okay, there's something strange to both TypeScript and Flow, and also to Elm, and this is structural typing. I will show this in an example. Say you have a class that's called dog, and it has a field name, and it has the method woof. Then you have an interface, which is more or less the interface like in Java. And then you can do this. You have something of type named object, this thing here, and you can assign dog to it, which would not work in Java because dog doesn't implement named object. But in both TypeScript and Flow and also in Elm, what is checked is not like the nominal thing, does it really implement it, but instead, is it structurally compatible? And it is, because the dog, it has a name, and that's all named object requires. That's very different from Java. Same thing here. Again, named object. This is an object literal, so you just create an object of no specific type but object, and it has the right field, name, is required by the named object, it works. This last example does not work, and it doesn't work because the created object has first name but not name. This is strange, so a class can be compatible with an interface without explicitly, but rather implicitly implementing it. That's strange, that's different. So nominal typing is when types are compatible, when their declared types match. And structural typing is when their structures match. All of those languages, they use nominal typing. Flow classes, which is strange and exception, are also nominally typed. That means flow classes actually only compatible if they're actually okay in their inheritance hierarchy. For TypeScript classes, this is not true. For TypeScript classes, they even match if they're only structurally compatible. And everything else in both TypeScript and Flow uses structural typing, just as I showed. Elm always uses structural typing, and it has to have an exact match. So there's no like sub or super type. It always has to match exactly. And this is important because it's very different from Java. Something else that is probably, yes, question? Oh, the question is, can I do inline interfaces? Yes, you can. So, yeah, possible. By the way, if it comes to Scala, I'm not very good at Scala, but I get the impression that the type system of Flow is very close to Scala. We will come to that. Maybe someone who has a better idea of Scala can answer later if it's true what I'm saying. So, nullability, that is, for me, I consider myself, well, maybe not good, but experienced Java developer. But I still make a lot of mistakes because of, I miss null checks. Who has the same experience? Be honest. A lot of, not everyone. Maybe you have different tricks. But for me, it's the biggest source of errors. I have code that I have 1,000%, if that's at all possible, of code coverage. I still get a lot of null pointer exceptions. Still. The code is complicated, but still. So, what can you do? First, a small quiz. Probably most of you understand what that is. What's the result in JavaScript here? So I have a function, it gets a parameter. If the parameter is larger than 10, I return cool, and if not, well, then not. And if I call it, I call to string on it, and I try to log it. What's the result? Anyone? It's very simple. It's not undefined, no? It's an error, yeah. So it's this thing here. Because this is undefined, the result, and on undefined, well, this is the way JavaScript works. I try to call to string, and that doesn't work. A bad thing. Not good. What would Flow say? So Flow works as a checker. It runs over that code, and you see it's just JavaScript. But Flow works on just JavaScript. So it's possible. No type annotations, but still Flow analyzes the code, like it flows through the code. And it will tell you, you can't do it, because that might return. That might return null, and you're not checking for it. Your code is not safe. Not good. Do something. What could you do? How would you check that? As a JavaScript or even as a Java developer. How do you do that? It's super simple. You just check it. And this is how a check would look like. You just check. This is like a little bit brittle shorthand for checking. If that is all cool, you just check, is it null? And if not, you do this. Now, surprisingly, Flow knows it's cool, it's checked. So the type system actually works together with the control flow in your program. And you can still see this is all just JavaScript. Not a single type annotation, and even not an extension to the language yet. It still works, which is pretty amazing. So if you have, well, JavaScript code that might not be brilliant, you can still run a Flow on it without any type annotations, which is nice. Okay, this is the interesting thing. Types are non-nullable by default in Flow. This is a big difference to JavaScript and then also to Java. That means if, well, maybe I show an example. Again, this is TypeScript, but same thing. if I do something like this, well, TypeScript does the same thing in this case. I'm trying to assign null to it, and it says, no, you can't. It must be a number. Because also in TypeScript, in this case, variables are non-nullable by default, which is strange maybe, but it's maybe the best idea of all those languages, to disallow null unless you explicitly say it can be null. It would look like this. So I can say it can be a number or null, and the error disappears. It might look strange, but this is like, well, trust me, for me as a Java developer, this is the best invention because it actually disables all null pointer exceptions or undefined exceptions. TypeScript, same thing. You can have the parameter here, but also in TypeScript, you're not forced to. Same thing. Again, same thing. In this case, it's not null that's returned, but undefined. And in TypeScript, you write it as void, also in M. That's the type. This is the return type, the inferred return type of this. So I'm not writing it here, but TypeScript infers this type because it knows, okay, one branch returns a string and the other returns undefined, which is typed as void. Good, I didn't write it, but still, TypeScript knows it. There's something that I totally dislike, but it's still in the language. And this is like a forced thing. I think is it also in Kotlin? Anyone know in Kotlin? Yes? Yes, it's also in Kotlin. And you can say, yes, yeah, maybe you can't like really enforce it that it's not undefined, but I'm very sure, so just do it. I don't like it because it actively disables the checks of the compiler. But you can still do it, but only in TypeScript. TypeScript 1 used to be very different because types were nullable by default, and we are now at TypeScript 2.1, maybe 2.2. And there's something you have to set in your options to actually enable the non-nullability by default. I did this, so it works like flow now. Now Elm. There's neither null nor undefined nor anything comparable in Elm. People who know functional programming probably know how do you do it there, or maybe in Java even. How do you do it without using null? Yeah, option, or optional, or try, or something. And in Elm, it's called maybe. And it's a predefined type, but it's very simple. Again, the syntax is strange, but this tells you I have a new type that's called maybe as a parameter a. It can either be nothing or just a. It's just something to tell, yeah, it's really a now. It looks like, if you're familiar with this, it's just ordinary, but it might look like a strange concept if you're not familiar with it. Let's have an example. So again, I have a function. That's the signature. It's int as an input, and it returns a maybe string. So it uses this type that has a parameter and creates a new type that's called maybe string. And then this is the method body here, right? This is the name of the parameter, num. So I check if num is greater than 10. I return just cool, else I return nothing. And Elm makes sure that I'm not returning anything else here, because otherwise it wouldn't match the signature up here. And then, if you want to consume that, you use something that's called pattern matching. So this is the call to the function. It's called foo. You put in 11, and then you match. If it is just message, you not only match it, but at the same time you bind whatever has been passed to message here. Whatever has been passed to just, you bind it to message and can reuse it on this side. So the return of this thing would be message. If it's nothing, you return just the empty string. And the type of the overall expression would be just string. And Elm actually enforces that you match all cases. Otherwise, it doesn't compile. It tells you, no, I'm not doing it. You're not matching the nothing case here. And this is, so as you see, there's no null, there's no undefined, there's also no need for it. And this is deeply baked into the language. It's a different solution to the null or undefined thing. but it requires to have completely new concepts. Okay, good. Generics. Probably the most complicated part. Still have enough time, fortunately. So, probably all know generics from Java. Who likes generics in Java? Okay, keep your hands up. Who completely understands generics in Java? You do? I have to talk to you later. But it's hard. I think it's hard. But for the most common types, it's not that hard. It's just very useful. I have a very non-genius example. It's like the common one. I have an array, which you can, in Java, it could also be a list, or probably an array list is closest. I have an array of type. Again, same thing, same syntax as in Java, probably taken over from Java. I have an array containing cats, and I have an array containing animals. And I just initialize, good, no cats inside, no animals inside yet. This is the array literal just to create an empty array. You can't do this, obviously, because this is not even an object, it's a number, it's a primitive. Not possible, error. Also that you can't do, because an animal is not a cat. Also not possible, same as in Java. But if you put in a cat into the cats, of course this is possible. And if you put in a cat into an animal, this is also possible. Because, why is it possible? Sorry? A cat is an animal, very easy. Or it's a subtype of an animal, right. Perfect. So this all makes sense. And this is the same in Flow and TypeScript, but there's a difference. So let's look at this. Again, same setting, but now we are not putting something into those things, but we're trying to assign them to each other. It's the same as like passing them into functions that accept certain parameters. And this doesn't work, and it shouldn't work, because those animals, they don't have like all the properties that you need for cats. That's an error. It's not good. Can't do it. Or like in Java. Not possible. This works. It might be surprising that it works if you are from a Java background, because you can assign all the cats to the animals. Why is it surprising? Why might it be a bad idea? It's not possible in Java, by the way. Yes? Yes, you can add dogs to cats. Let me show you how. That's exactly what I'm doing, so it's not a brilliant example here. I push a dog to animals, which is okay, because a dog is an animal. Why should I not do it? I can do it. I could also add an animal, which also is good. Why not? Animal is an animal. But now, as those are now the same objects, right? And the same references, the same arrays. They effectively land in cats. And that means if I now, for each of our cats, this is like exactly as in Java 8, except that this is a double arrow. You see, you now have the cat in it, Purry, which is really cat. Okay, but you also have the dog, Brutus, and you have Twinkie, which both are not cats. So this is possible in TypeScript. So obviously, it allows you to write code that is not correct. Java wouldn't allow you this. Let's see why they do it. Maybe compare it to something else. But obviously, this is not good. Birds and dogs are cats now. Now Flow. Same setting, same first example. You try to assign animals to cats. Not possible. But now the other way around, the other way around is also not possible. Same error, which is surprising, right? But it doesn't have that caveat. So in Flow, it's not possible either this way or the other way around. Which is a good thing, because it disallows code that's not correct. But it comes with a flip side. Look at this code. I have something log animals, and the special thing about this is it doesn't change the stuff that gets passed in. So I get passed in animals, And I'm not doing anything to it, like not modifying. I'm just logging them out. So this is perfectly safe and sane code, right? Just doing it, calling it with cats, not a problem. So this is cats that I'm passing in. It expects animals, it should work, and it does in TypeScript. It's potentially not safe, as I could write something in here that actually puts something into animals that's not a cat. But it does not. So it's potentially not safe, but this special code is safe. Now, the flip side is, even though Flow disallows code that's not correct, it also disallows code that's obviously correct. This is safe, why not do it? But it's not legal in Flow. And now something I have a hard time, still have a hard time with Java generics, but in this case, Java is actually much better. So you write something like this. You say, I accept anything that extends animals, but effectively only as a read-only thing, which is safe. And you see the same code here. Good. And this now is actually illegal if you try to modify the thing, because it's no longer safe. It could be something bad in here, like this. If you pass in cats and you add an animal to a cat, not good. So Java's better here. None of the two type systems, Flow or TypeScript, can actually handle that. Maybe we have time for some type inference magic, just to impress you. I have a dog class. I have animals. I push in the dog. And now, look at this. If I for each of it, both TypeScript and Flow now know, yeah, you just pushed in a dog. You didn't specify any types, but we know everything that is in animals must be a dog, because you only added dogs. So it's not only like that it looks from a very superficial point at my code, but it actually goes through the code and it sees, yeah, good, not a problem. Something that Java, for example, could not do. And it says, yeah, that's perfect code. All the animals are dogs, do it. And now, even one more step, if I add a cat later, like later in the code, like first I do this and then I add a cat, this one, I push it in, TypeScript would still say this code is legal. It still says it's legal because you're pushing it later. It actually knows that, which is pretty cool, but Flow fails. But still, both accept this first part, which can be really nice at times. So often you don't have to even consider what's your type now, because the compiler can do it for you. Quite nice. I like it. I'm impressed. Good. What about Elm? It doesn't have classes or subtypes. And one of its mantras is simplicity. That makes it simpler. It has records, which is just like a JavaScript object. It has data structures like a list. So I create a new type. It's called animal and has a field name. It's of type string. Just the syntax is different, but you can understand that easily. I create a new animal, animal 1. It has one field name, and that's the name. This is how you, like in generics, define a list only containing animals. And if you put in animals like this, it's all cool. Good stuff. And then I have a cat, which you may notice, it also has a name, as something else, the code color, that is like, how does its back look like? Is it gray or something? There's a list of cats, I can also put in cats, good. But now, if I try to assign them between each other, I have another list of animals, more animals, I can assign animals to it, because the types perfectly match, perfect match. But if I try this, if I try to put in cats into animals, it doesn't work, because it tells me, no, you're missing the code color. And also, if I try to assign animals to cats, not only cats to animals, but animals to cats, same problem. Because types always have to match exactly. So there are no subtypes or something, or supertypes in Elm. The match always has to be exact, which makes it easier, but maybe sometimes more cumbersome. Wrapping it up, TypeScript generics are always covariant. So if the type is is a subtype, the generic type, it works. That's most intuitive, and it's very easy to understand, but it's not as powerful as it's like flow. So there's always like, do you want this? Do you want simplicity? Do you want it to be understandable, or do you want it to be powerful? And flow goes the other way. Flow lets you actually choose what kind of variance you want. The array that we're using uses exact match. That means invariant. And you can also choose covariant or contravariant. I think that's the same as in Scala. Can someone, yes? Definition side, variance, yes, is it true? No one nods, but no one also shakes his head. Probably true. That is more expressive, but it's also harder to master, and it also disallows some correct cases. Yeah, because you have to understand what that means now. In this case, you probably don't have to understand it. In Elm, as I said, it also has something that's similar to generic data structures like the list, but types have to match exactly, perfectly. Okay. That's also very interesting because mutation is one of the biggest sources of errors in my code. And in TypeScript and in Flow, it's like exactly the same as in JavaScript. You have const in JavaScript, which is like final in Java, and you also have immutable data structures, but you have to use them as additional libraries. TypeScript also has read-only, which is taken over from C#, but it's just for properties and classes. And in Elm, everything is always immutable and always const. So you can't change a reference to anything, and you can't change a value inside a record. It's also not possible. But how do you do it in Elm? I mean, I said you can't change anything, but probably that sounds weird. I mean, if your program doesn't like evolve over time, it's probably meaningless. So how do you do it in Elm? And the answer is you don't do mutations, as I said, but instead you make copies. You make a copy of one record, which is like an object, and you take over most of the properties or some of the properties and you change some others. And this is like a lot of people do it in JavaScript as well. And I think this is also like many people do it in Java, but I'm not quite sure. So again, let's consider we have a cat. It has a name, called color, and an age. This is a cat, Perry, again, it's gray. And then you have a method, in this case a function, called have birthday, so it's the cat's birthday, gets 1 year older, it gets a cat and returns a new cat, because you can't modify a cat. And this is how you make a copy. This is special syntax. You say, yes, I take the cat, which is passed in as the parameter, I copy all the properties of the record, and I change the age by accessing the previous age, adding 1 to it, and then this cat gets a new age. It's very similar to the object spread notation in JavaScript, which you may know or may not. So this is a nice and handy syntax for it. So if you call have birthday on some cat, if of course returns a new cat, and Elm enforces this. And as I said, this is a programming style that's also done a lot in JavaScript. Good, still time. There's any type. You saw it a little bit earlier, and it's very important. If you specify in type as any, that means you can selectively disable type checking. Like if you do with Java generics, if you don't use generics at a certain point, even though you should, you disable type checking for a larger part of your program. If you do this, you have function, you get a, it can be any. That means for the whole function, the whole type checking is disabled because you said so. You can do it. And that means you pass in 10. Yeah, it's any. But you can also say the return type now is string, which is obviously not, but you say it is. Obviously, this is never string. I mean, this is number. And you can also pass in a string, which doesn't make a lot of sense, and you can say the return type is Boolean now. Because you, in this case, actively said, no, whatever you pass in, not your business, compiler. So you can selectively disable, which is a bad thing because it now gives you a backdoor to runtime exceptions. So it's supported in Flow and TypeScript too. In Elm, not possible. There's no backdoor in Elm, at least not in the language itself. Okay, nice. Are you still, yes, you still look interested, good. Because union types is also tricky because it doesn't exist in Java, at least not in this style. Union types are sometimes called, I've been told, algebraic data types, tagged unions, or disjoint unions. I don't know, but this is what people tell me. And it's there in case you have a data structure that, well, like sometimes it looks like this, and sometimes it looks like that. And I have an example. Say you make a call to a server and you get a response, and sometimes you get a result, and sometimes you get a failure. So this is a type definition. This is both in Flow and in TypeScript. And this thing here tells you it's a union type. It's an or. It might be either this or that, which is also, as far as I know, not possible in Java. Now, what do those types mean? So first, result. It has one field called status, and it has to be done. So this is also interesting. So this type thing here tells you it doesn't not even has to be a string, but it has to be exactly this string to be of correct type. And if it is this, then the payload, whatever comes from the server, is an object. But if it is failure, it again has the same field, like the same name, but now the string has to be error. And in that case, it's the HTTP error code. That's possible. What can you do with it? I mean, well, why is it interesting? Because it allows you some nice code that's also checked. Let's say you pass on a callback you make the call to the server, you get back a response, this thing here. You can check the status because the compiler knows both success and failure. What was it called? Let me get back to both result and failure have field status. So the compiler knows it's safe to access that field, not a problem. But it's not possible to either access the payload or the code because you still not know what is in that status field. It's obviously not safe, right? So what do? You just switch over it. It's actually the same as in Java. And you check what is the status here. And then if it is done, magically, now the compiler knows at this spot here, without doing any typecast or something, it knows, of course, if it is done, it has to be the result thing, and it has a payload. And if it's error, it has the response code, which is nice, because you can write code like this, which is now safe. Elm, also very simple. It looks so similar. I'm always surprised. So same thing, you have result. In this case, it's a little bit more simple. The result is just a simple string, and failure is just an int. And you can, again, use pattern matching to switch over that. So you get the response in. This is the same callback method. It's a little bit more concise because I have less comments. And I switch over this. If it is a result thing, I just take the payload. If it's failure, I can do something and then turn it into a string. And this is how you would call it. Like, this is the call. I call this method here up here. I create a result of response. It gives me back response. In case of a failure, it tells me I messed up. It's 400. So, it seems to work well because we're coming to an end. Wrapping it up now. I showed you 3 different type systems, and where do they excel? I mean, where are they really good? The first one, TypeScript. For me, coming from Java land, a lot of things are very, very similar, and it enables perfect IDE support. If you use IntelliJ IDEA, it's almost as good as Java support. Even Visual Studio Code that I showed, it also is very good. And that works because TypeScript comes with a language server. That means the TypeScript compiler is not only a compiler, but it compiles the code, and at the same time it creates ASTs, some type information inside of it. And now the IDE can ask the TypeScript language server, what references are here? How can I complete this method? And that means all the logic is built into the compiler, and the IDE doesn't have to do much anymore. And that means all the IDEs are more or less like equally good. And this is a nice idea. It comes from Microsoft, the idea. And it also has a lot of third-party declaration files. That means if you're using untyped JavaScript, which is cool for TypeScript, it can either infer the type for you, or you add external type declaration files, when there are a lot of them, and then you have explicit type information. It's also very nice. Flow has been designed from the start not as a compiler, but as a checker. That means it doesn't compile your code. It runs over a checker, over your code, like a linter, maybe. And it even works with existing projects like, pretty easily. So if you have a large JavaScript code base, you can seamlessly add step-by-step type checking using Flow. It's also very nice. It has more powerful generics, and has nominal typing for classes. It might be a little bit abstract now, but if you use that, it feels like Java. It's also very nice. It's a very good solution. Probably my advice would be if you start from scratch, use TypeScript, and if you have a big JavaScript program, use Flow. Now Elm. Elm is completely different. I mean, it's almost not right to say it's a type system for JavaScript, but rather it is a language of its own that compiles to JavaScript and has been intended to only compile to JavaScript. It's a different approach because it's not adding stuff to the JavaScript language, taking all the maybe bad things with it, but creating from scratch. And that allows it to have a very simple type system, and is always completely typed, always. There's no way to like leave the type system. Something that I also like very much, everything is immutable and always constant, everywhere. It's also great because you can't do certain mistakes. And it also makes your program free of runtime errors. And people who use it in real big applications tell me it's true, which is interesting. And if you're just starting, it comes with a complete package. That means like all the stuff that you need to create web applications. Maybe also interesting. Finally, these people helped me with it. Those people from the different teams of those languages, they all helped a bit. So this is a thank you to them. And with that, I can close, and I don't think we have much time for questions. 2 minutes? Questions? Yes?
What about integration with existing third-party libraries? Do they all handle them as untyped? Do they do the type checking inside of them?
So the question is about integration of untyped JavaScript. I had to take it out of the slides because they were too long. So as I said, with TypeScript, you can just use existing JavaScript and it tries to infer the type as best as it can. Same with Flow, but both can also add additional like external type information, like, I don't know, header files in C or something. That's both possible in Flow and in TypeScript. Unfortunately, they have to use different external type declarations. They're very similar in syntax, but not always similar in semantics. So they need different type annotations. And both have, on GitHub, large sets of predefined type declarations. And you can use them, but you're not forced. With Elm, it's very different. So Elm has to have a special interface to native JavaScript stuff, and it's almost like making a call to JavaScript, and then creating that, well, from that JavaScript type, creating an Elm type, and it's more tedious to do it. Yeah, in short, it's more tedious to do it in Elm. And also, if you include like general JavaScript stuff in Elm, of course you don't have all the guarantees anymore, like that you never get a runtime exception or something. Question answered? Okay, good. Last question?
So this TypeScript thing where you assign the cats to the animals, is there a compiler flag to disallow or that?
Oh, it's about the incorrect assignment from the, what did I do? From the, yes, so I took an array of cats and assigned it to animals, which is unsafe. If there's anything that would warn me, I'm not aware of it. No. But it would be great, right? At least some, yeah, perfect. Like a warning tells you it might be unsafe. Yeah, but I don't think there is. Okay, we're out of time now. Thanks a lot, and the slides are online on my GitHub, GitHub, Twitter thing. Thank you, and bye-bye.